Hopefully I am live. Hello all. Can everybody hear me and see me? I hope so. Let me know if I'm 5 by 9, 5 by 5, however you want to state it, I'll take it. So let me know. Wasn't that long ago that we were right here doing the same thing. I feel, and I'm wearing the same red shirt. I think I'm going to have to get a bigger wardrobe because I only have so many red shirts that I can wear. So wonderful. Okay, looks like I see people tuning in from Maryland. Mike Richardson, thank you, Mike. You say sound is good. I believe Mike Richardson and Jerry Ryan are both in the chat. They're going to be the moderators of tonight. They're always the moderators. They're wonderful people, and they will help elevate your questions if they're not seen by me. Today is probably going to be a bit lively because the solar storm, the first of many, has hit. So I'm expecting to see lots of questions and lots of talk, as I can tell already by the chat. It's just brrr. You guys are machine gunning the chat on by. So I will likely miss a few things. So if you really need to get your question heard, if you haven't, you keep putting it up time and time again, and I haven't seen it, elevate it through one of them, because I always look, when I see them, I always tune into what they're saying. So by the same token, also be nice. They are not afraid to boot you if you get out of, if you get off topic or harass people. So please be nice. We're all here to learn. This is a very encouraging environment. Now, before I start, I see hello to everybody. I'm not going to linger too long because I know it's a bit late for some of you, especially on the East Coast, or if those of you, if you're crazy enough to be over the pond and still awake, should almost say good morning. It is, I'm not going to linger for very long before I jump into the briefing, but I will say before I start, do not worry. This is not like the Gannon storm back on May 10th, okay? This is not a repeat of that. This is actually a bit weaker. You'll see in this case, it is another solar storm train, which is typical when we have these very big events. They don't typically happen once. There'll be like, a whole string of them. As I've said many times, when we have a bad actor or several bad actors on the sun, they have a tendency to be just angry, and they'll machine gun, rapid fire stuff all the way across the disk until they disappear behind the west limb. So it is not uncommon to get this many storms in a row. What is keeping us on our toes is the fact that we have two separate clusters on the disk that are doing the same thing, and we'll talk more about that in a sec. So it's more of a headache than anything for us, but the storms that have been fired have not been as powerful, believe it or not, as what we got during the Gannon storm, set of 8. And so you'll see it will unfold more slowly when they hit, and likely the peak will not be quite as high, but it could last longer. And that in itself is a good and a bad thing. Just like everything in space weather, there's a good and a bad thing when it comes to that. I see people saying, speak up. Some people say audio's fine, and some people say my audio is low. Let me know if it's low. It's very low. Okay. Are people saying my audio is low? It shouldn't be. I will turn it up if it needs to be. Hold on. I can turn it up a little bit here. Check, check. Is that a little bit better, guys? And if it's still low, hold on. I can turn it up quite a bit if I need to. Hopefully it's not going to distort now. Let me know if it's beginning to distort, because I don't want it to distort. So I turned it up a few dB for those who have asked. That's better. Okay, people said good. Good. Last time I turned it up and everybody said, oh no, it's distorted now. So you can't win one way or the other. Okay. It was fine before you turned it up. Some people think it's great. Okay. Good. It sounds fine now. Wonderful. Okay, guys. So let's jump into it, okay? I'm going to turn the chat off and we will get going. All right. Hopefully that starts this thing moving off. Okay, so as you will see immediately, this is very similar to my typical Earth-facing disk. This is starting around right early on the 27th, but you notice I have this cute little guy up here. And no, those aren't aliens. This is just filter wheel issues, so don't worry about it. Those aren't aliens flying by. But this is the coronagraph view, and the reason why I have the coronagraph view up here will become abundantly clearer in a few moments. There have been literally machine gun firing of solar storms from two sets of clusters here. For those who have not been catching up on my updates, oh, We also may have an echo. Gosh, I hope there was no echo. Okay. We had machine gun firing from this set of regions here, okay, and from these two regions here, and we'll talk more about them in a minute. But these two sets of regions, as they've been synergistic in the sense that they've been connected to each other, because they're kind of like, they're like the twins, that this guy gets hurt and that person feels it, right? They've been trading shots back and forth, and that causes real problems for us, because it's not only causes rapid fire machine gunning of events, but it also makes it extremely difficult for us to separate solar storms and even separate source regions. So you will see through the course of this, this early part of the presentation, you will see me showing different versions of the disk and then the coronagraph. So for this part, the disk is big, the coronagraph's small. In the next part, you'll see the coronagraph will be big and the disk will be small. So as we start off on the 27th, that's really when things began to get exciting. We started having some puffs, as you can see right here. We had a big far side blast, which I went over in a previous briefing. So anyone who looks at this at that time and sees this massive solar storm kind of moving off on, to the east, that was a far-sided blast from a region that is yet to rotate into Earth view, but is just beginning to, and we'll talk more about that, good old region 3738. But at the same time, you saw another puff here, right? So there were two puffs if you saw. Now check it out. Right up on the coronagraphs, you see these two little small puffs. Those become bigger. Those are the first two storms, believe it or not, that are hitting now. We'll talk more about those later. But I'm going to just kind of let this play out, because I want you to see how incredibly active region 3762, region 3764, and region 3766 get. They just, as you can see here, at the beginning of the 28th, you got a big shot being fired here. Yes, that caused yet another solar storm. You'll see it up in the coronagraph kind of coming out. That is the big halo. That's probably one of the fastest and most intense storms. That's like storm number 4 or 5. Okay, that's how far down the train. That's how many solar storms we've already seen. So I'm not stopping here, because we will in the next scene. You'll see. We'll stop again. I'll go over them a bit more. But I just want you to see, these guys are like trading shots back and forth. Okay, so we are having a lot of M-class flares. I can't even count how many. It's just since the 24th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. At least 14 M-class. Oh, well, more than that, because I've got smaller ones I didn't even count. 14 big M-class flares and an X-class flare. So that's what you're seeing in this whole mess. But it almost looks more like a pot of boiling water than it looks like a solar disk, if you can see that, because there's just so much going on. There's so many little whistles and puffs. You're seeing them here. You're seeing some on the far side being launched, and so we've had to separate out what those are. But it's mainly due to region 3762 and region 3766. We will talk about these more in a few minutes, and I'll show you how region 3766 and 3764 are almost colliding right now. And that's what's causing a big up in the X-flare potential for these regions. But the neat thing about having so many, there's yet another one. It's a big blast right there. And I think that's going to end it. So if I back up just a smidge, so you can see that again, that's the big one for the second to last one. We ended up having a big X-flare. And then you notice this one fires off just shortly thereafter. And we've actually had something like 2 flares since then, but this was as of 1500 or 1543 UTC, and it looks like we've had 1, 2, 3, I'm looking at my chart here, about 3 big flares since then. So I couldn't even capture them all, because I had to actually, come and actually make content for you guys. So as you can see, this has been a massive soup of stuff, okay? Very, very difficult to separate out. I will do that here. You'll see when I make the coronagraph big. Very, very difficult to separate out which solar storms are coming from the front side, which are coming from the far side. Do we model them together? Do we model them separately? If anyone was wondering why it took Space Weather Prediction Center so long to put out a multi-storm Enlil run, it's because of that. I wouldn't be surprised if they tried multiple times and the whole thing just cratered on them and diverged, because it's very, very difficult to run storm after storm after storm and having them collide and get something out that's realistic. And we'll talk more about that in a sec. But that's what's been going on in the last 24 hours. Like I said, if you want to see more on the actual solar storm, details of some of the earlier storm launches, then look at my prior briefing. It wasn't a live briefing, it was a formal forecast I did just a couple days ago. So I'm not going to go belabor that because we already have done that. What I am going to do though is talk a bit more about these regions. So down here in the bottom panel, these two are synced, the top panel, the bottom panel are synced. What you're looking at here is just the regions rotating across the disk. This is with HMI data, so we're looking at the magnetic complexity. Plus I've overlaid a little bit from 131. This is where you see a lot of flares, so you get an idea of when these regions are flaring. But this disk actually rotates. In this one I froze them in place so that you can actually see the evolution of these structures as they move. Okay, so if you want to see the time range, this is what we're talking about. So basically over the last 2.5 or so days, you can see, actually let me start it back up because I want to show you before I start looking at this. Look at region 3762. This is the one that was really starting to flare first and get far more complicated. This set of regions back on the 26th and 27th really weren't all that complicated because they were multiple regions but further apart. It's only been in the last couple days that they've really started to grow new ones. And really, the big boy right here is region 3766, which began to emerge in between 3764 and 65, okay? Which is, strangely enough, kind of similar to what happened with region 3664. Oh my gosh, look at that. 3664, which I think was the Gannon one. Wasn't that the Gannon one? Gosh, have we gone 100 sunspots since then? That's crazy. Anyway, if you remember the Gannon region, and we had another region, I think it was 3668, and then we had a new region pop into the middle. So it was kind of the similar thing, but in the last time, they all got so close together that they just became all one region. Here, they're staying far enough apart that we're not getting those massive X-class flares, at least not yet. But region 3766, as you can watch it grow here, look at it growing pretty quickly. In fact, you can watch region 3768 begin to grow quite quickly too. All of these regions here really start having a lot of fun over the last 24 hours as they grow pretty dramatically. And you can see a lot of the connectivity between these regions, region 37, 62, and 68. And then overlying fields are what are connecting these sets of clusters. So we've got two sets of clusters, right? Basically 37, 64, 65, 66, and 67, as well as region 37, 62, and 68. So those are the two clusters of regions that are not only interacting with each other, but they're also interacting along, intercontinentally. This is the pond. Here's the United States, here's Europe. I'm just kidding. Anyway, this is kind of what it looks like right now, is that they're egging each other on. And so since about the beginning of the 27th, we've just been having massive flares. Our flare noise floor has really increased. We're sitting almost at an M flare level. I keep looking down at my X-ray flux here. We're sitting almost at an M flare level for radio noise. So amateur radio operators on the Dayside, this is what you're dealing with right now, okay? But watch region 3766. Look as it continues to really squeeze and squeeze in here. That is going to be a real issue for us here over the next few days if this thing doesn't quiet down or the tension doesn't let go. So we're really watching this one. This is the region that is going to be up and coming. And of course, I don't have to explain, region 3762, which is the region that has been firing off the biggest of the flares. Here's one of the biggest yet, right? This is the last one I caught before I had to stop, which was at, about 15, what does that say, 13 or 1500? I can't even read it. It's beginning to change, I think. Let me back this up a little. 1330, yeah. So right around 1330 was the last big flare I caught. So this region, remember, I've said this many times, as a region rotates to a certain longitude, if it starts getting really active around that longitude, like this one has over the last couple days, then the next set of regions that rotate over that longitude might also start getting really active. So let's see whether or not this cluster, even if it begins to quiet down over the next couple days, which I don't think it will, but in case it does, don't think that we're out of the woods, because where this region is in longitude right now on the sun, this cluster will be rotating to in the next couple days. So we may have a big flare up again when this set of regions, rotates to the west limb. So obviously we're going to have big chances for radiation storms as well. So expect issues with GPS, expect issues with amateur radio. Dawn and dusk is going to be a bit dicey because we're going to continue to have these very large flares. Okay, so remember I told you the next one I was going to have a big coronagraph and a little disk? Right. So this is the one that actually takes apart what's going on with the solar storms, okay, from a coronagraph perspective. So this disk will flash on and off, and I've got it highlighted the source region. And some of my colleagues may say, well, that's not really the source region. It was more over here. Okay, fine. Okay, fine. It's really hard to tell because if you watch this, it's just like I said, more of a boiling cauldron, if anything, with just a lot of little puffs everywhere. You tell me which one connects with it, which one. I can only get reasonably close. So, and I've only pulled out the biggest of the puffs, okay? And out of the big 10 puffs that you will see, if I may call them that, in this big solar storm train, NOAA and well, NASA models all of them, but my goodness, I can't string them all together. NOAA luckily modeled four largest of them, the most Earth-directed ones, in a row, and we'll talk about that in a minute. So here's where the first set of puffs were, right here, and you can see, okay, that was the far-sided blast, but you can see we had a first puff and a second puff right here, and these are the two storms. As a matter of fact, I've got them labeled. So we had you can see a halo right here, and you can see a halo in here. Okay, so these are the two halos, the first of which, the outer one, is the one that's hitting now. So as we go through the deep dive and we talk a little bit about the solar wind data, expect as it unfolds, it's going to be kind of an ugly storm. I'm not expecting this to be beautiful. I'm expecting it to be kind of a composite event because we've got these two storms that are literally smushed and, jockeying for position. Okay, so that's number one. All right, so that's the first bit. Now, we have another storm, hopefully, whoop, oh, that was cute. We have another storm that happened, and I was trying to stop it before we got to storm, before it. Okay, you can see that small puff there. Right, so this will be storm number 3, and you can barely see it. Hopefully I paused it there. You can see this tiny little halo. Okay, see that? Very, very weak. Is this Earth-directed? Partially Earth-directed. Okay, so that's storm 3. Now here's storm 4. Once again, same thing. Region 3762, this little puppy just was very storm happy. Fires off another one. There's storm 4 right there, and you can see the inner part of this halo. And it actually, as it moves out, it gets dimmer, of course, but you can actually see a little bit of this inner halo clear down in here. So this is, again, a partly Earth-directed solar storm. Then, of course, the big one fires. This is when region 3766 wakes up and begins to really emerge. This is one of the big flares, and it just causes all sorts of stuff to come out in all of these different locations. And that gives us a really ugly halo. The modelers at NASA were sharing with me how frustrating it was to try to model this thing because there's so many different craggy parts. Which part do you model to get the speed? So this is going to be a bit dicey. It ended up being, as beautiful an eruption as it was, it ended up being a bit slower as it came off the disk than we thought. So that was why when you saw, if you saw me say, I think this could be a G3 to a G4, and then we downgraded it to a G2 to a G3, yeah, that's why, is that this thing in coronagraphs turned out, it didn't move all that fast, and it was kind of weak. Look at, see? So that was that. Okay, then we had another little puff from this region. There we go, whoops, and then, whoops, let me back it up. I forgot, this is a two-parter. It's hard to remember them all. So we had a little puff here, whoosh, and then look down here, we had another little puff, whoosh. So we get 2 whooshes out here, right? Storm 6 and 7. You guys keeping count? See why I needed to do this twice? Oh, my goodness. Okay, this took me all day to do, by the way, so this was intense. So here's the next one, right? Now we got another explosion of the sun. So that gave us, whoop, let me go back. That gave us a little light guy. You can kind of see this structure in here. Okay, another wispy, partially Earth-directed. We'll see. Not much there, hard to tell. Okay, but that's storm 8, and then we had something lifting from the far side. I believe that was what that was. It was up here. So that's not what this is not an Earth-directed solar storm. But as we watch here, we get whoosh, we get boom, and then boom. So we've got 2 booms, and we've got one boom, and well, not quite this one, but this boom and this boom down here. Okay, and then it also let off something down in here. So there were actually 3 storms, but 2 of them look like they're at least partially Earth-directed. This one here and this one here. Okay, so 3 solar storms launched almost simultaneously. That's where we get storm 9 and 10 because one of them is not Earth-directed. Okay, so 10 solar storm launches that are either Earth-directed or partially Earth-directed in just a few days. We can't even keep on top of it. It takes longer for the model runs to go than we can, possibly keep up with this. And that's partially why, if you wonder why the Space Weather Prediction Center isn't modeling every single one of them, they can't. They just can't. It's just too much. Okay, so that's how that goes. Now, let's talk about the ones that they did model. So as we switch to our solar storm prediction model, of course, this is NLO, this is NOAA's version of the model. The top panel's density, the bottom panel's velocity, and you're looking down at the sun from the North Pole with Earth being off to the right. And as I set this in motion, you shall see, hopefully it'll move. Okay, there we go. How many is that? 1, 2, 3, 4. Can you see them? Hopefully you can see them. 1, 2, 3, and then the 4th one's coming. Or did I miss the 4th one? I think I missed the 4th one and the first 2 already connected. Yeah, so these were 2. I think you can see 2 in here. So I back it back up. Hopefully you can see. So there are 2 in the first kind of casing there that collided, 3 and then 4, okay? So these are the main 4 that are coming toward Earth now. The very first set, like I said, is hitting us. I'm expecting it to be a bit on the ugly side. Remember, if you remember the halos, though, they weren't all that intense looking. Nothing like the big halos we had from the sun's far side from region 37, 38. That one is still, we'll see when it rotates into Earth view if it's got much left to it. Well, I don't know, it's hard to tell. At any rate, so when SWPC modeled this, they show kind of an impact. It's going to be a kind of an ugly impact, as you can see. Impact was supposed to be about 6 UTC on the 30th. Well, it's a little early. Expected that, we had a little bit of stuff going on in front of it. There's a little stuff behind it. There's just a lot of mini solar storms that are kind of clearing the way a little bit. So these storms are coming through a bit more unimpeded. And that means what we call preconditioning is going to mean that it's got a smooth sailing for some of these storms, which will allow them to reach us a lot, in a lot more pristine condition. But sadly, they will be clustered up against one another a little bit. Now, for those of you who remember the Gannon storm, these things all merged together, right? And some people use the phrase cannibal CME. Please don't use that phrase. Nat Gopal-Swamy hates the fact that he coined that because everybody misuses it. They think that these coronal mass ejections, these solar storms are eating each other. They're not eating each other. They have magnetic field in them. So even though these look like they're merging together into a single structure, they're not. They're just pancaking each other. Okay? They're just layer upon layer upon layer. So think of it as like a 5-layer club sandwich or something, right? A club meaning beat you over the head with, right? So it's a club sandwich, okay? So this thing is coming along, but they're not coalescing into a single structure. And even though it kind of looks like it is here, in real life, the models can only imitate the magnetic field to such a certain degree. We have to keep the magnetic field passive because we couldn't run the models fast enough if we had it be active where these structures will stay separate. So they kind of glob together, but that's not the really way it's going to be. So what that means is that you get a very tall and dense structure. Don't expect them to be quite this intense. This is showing, a density of 60 particles per cc. I don't think we're going to see something quite that intense. And it also causes it to be squished together. And I don't think we're going to see something nearly that squished together. I think it's going to spread out over days, more like what we see with the speed. Okay, so this top panel here is showing the density. The bottom panel here is showing the speed. This is at Earth. Okay, so we're worried about Earth only. So you see how the speed kind of steps up slowly, a bit more spread out than this is. Yeah, I would kind of expect the magnetic field structure to look a bit more kind of like this, a bit more spread out. So what that means, and I'm sorry I can't go further with it, we'll do that in the deep dive. I paused my model and froze it at that point, and I didn't think, you probably should have played it out, but oh well. We'll do that in the deep dive. But what that means is that compared to the Gannon storm, okay, it should come a bit more spaced out, like waves, where we're actually able to tell the difference between one structure and another. but it also means that the magnetic field strength is not going to be quite as strong. Even at its peak, it's not going to be quite as strong. Now, the good thing about that, okay, is that we're not going to hit G5. Okay, I'll be surprised if we hit G5. Okay, could we hit G4? Yeah, I'll go into the 5-day outlooks here in a sec. So we could hit G4 maybe sporadically. If you look at HP 30, for example, we'll hit it sporadically and jump down. I don't think we'll see a 3-hour averaged G5. I think that's just too much for this cluster, or this solar storm train, rather. But what it does mean is that we'll have a lower intensity, longer duration storm. Okay. Now, the good thing about that is, okay, you're going to get a bigger chance for aurora because you get more times. You know, if it's cloudy today, maybe tomorrow it won't be, right? So you'll get a bit longer chance to chase aurora, and that's wonderful. Where that kind of stuff makes me feel a little bit uneasy is only because I don't like long sustained hits. I don't, even when they're lower intensity, I don't like it when they're longer. I would rather have a strong storm that gets over with. You know, as long as it's not like Carrington class, right? I like a stronger storm that gets over with quickly, as opposed to a slightly weaker storm. So if we end up hitting G4 levels, which I don't think we will, we'll probably hit G2 to G3. I think this one has been forecasted pretty well. But if we are sitting at sustained, let's say, strong G3 for 36, 48, 72 hours, I am not going to be happy, and neither are the power grids. Okay? They don't like it when it's sustained because heat takes a long time, right? It's an integrated effect. So it's going to get intense for them. So let's just pray that, you know, we get breaks, right? We can get breaks in between the storms. So we get a hit and then we get a break and it calms down, and then we get hit again and we get another break. So that's my only thing. If you're worried, if you want me to be totally honest with you, that's my only concern about these storms when they're not, you know, when they're just so long, when there's just so many of them. So we'll see how it is. I'll talk about the deep dive. We'll take a look at the intensity of them. But a G2 to G3, I think, is a probably pretty good estimate of where they're going to be. Now, where it's going to be, is it going to be a strong G3? Probably not. Probably a weak to moderate G3 at its peak. Okay. But I've been wrong in the past, and this cycle has outperformed. So I'm a little bit sheepish to get too intense with my predictions, you know, because you just never know what you're going to get, right? It's a box of chocolates. Okay, so let me go ahead and move on. Oh, I just want to mention, yeah, I should mention that we are now moving through the third quarter phase on our way to a new moon. So the new moon, I think the moon will be like on the 3rd or something. I think by, what is it, the 2nd? The 2nd, the moon will be about 4% illuminated. So, you know, not a bad time to catch aurora if you can see it through the wildfires and the smoke and all the other haze, light pollution. You know, the moon at least isn't going to be contributing too much. So, okay, let's move on to our 5-day outlooks. Now, talking about our solar storm conditions and aurora possibilities, over the coming week at high latitudes, NOAA is expecting a severe storm, of course, especially on the 30th, but giving us about an 80% chance of a severe storm at a G3 level, okay? So that is going to last easily through the 30th and possibly in through the 31st. We still have about an 80% chance of a severe storm, but we're going to drop down to a G2 level by the 31st, okay? Do I think that's right? I don't know. I would probably stretch this saying we could have severe storm at high latitudes only on Wednesday, and then drop down to a major storm on Thursday, and then we begin to move out of it. And I think by Friday we're going to start seeing it calm down. So we may or may not have aurora possibilities, maybe some sporadic aurora, that type of thing. But by the 3rd, probably getting down to a pretty calm. We're not expecting too much more. But, you know, we do have a few more active regions coming into view. So, you know, this may not last as long, this quiet may not last as long as we'd like. And then if we switch to mid-latitudes, oops, if I can get to mid-latitudes, come on. Hello. Are you going to go to mid-latitudes for me? There we go. Okay, at mid-latitudes, well, expecting major storm conditions, definitely. G2 is likely. Possibility for G3 is, I'm going to say about a 35%. I think NOAA drops down to a 20% on Wednesday for a major storm. I still think that the chances for a major storm will be a bit higher. These 2 days, I think, are going to give us some decent stuff because we do have a few storms in there that they don't even have in their models yet. So I think it could linger longer than they might think it will. But if we drop down to minor storm conditions by the 1st, definitely going to have, around G1 conditions with about a 20% chance of a major storm on the 1st. And then by the 2nd, we'll drop into an Aurora watch at mid-latitudes. Don't really know if we're going to see that much more Aurora. Just the dedicated folks should be still out there chasing. And then by the 3rd, we should definitely be calming back down. And then looking back to the sun, right? Because we might have some more chances for bigger storms with that sneaky region 3738 rotating back into view. And by then, that region may actually be getting close to the Earth strike zone. So we'll end up seeing there. Okay, so now as we switch to our solar flare and Dayside radio blackout outlook over the coming week, we are sitting in the 220s right now for solar flux, and that's likely going to calm down just a smidge. But I don't want to calm it down too much because, again, region 3738 is going to rotate back into Earth view, and I don't really know what it's going to be giving us. If there's anything left, this is that region that had that X14 flare, and then the X like 6 or 7 flare, and then another X11. Does it have anything left in its tank? It's hard to say. We don't get good enough views from Solar Orbiter to really know. So we'll just have to see. But right now we're definitely dealing with some severe noise on the bands, and I'm going to keep that all the way through the 5-day because regions 3766 and 3764 especially are still going to be quite noisy, and then this new region likely will bring quite a bit of noise with it as well. NOAA's giving us about an 80% chance of R1 to R2 level radio blackouts right now. That might just downgrade just a smidge, but I don't think it's going to back us out of the severe noise category because, we're almost sitting at an M flare level for solar, for X-ray flux right now. So that's a huge noise level for everyone. About a 25% chance of X-class flares that's a radio blackout at the R3 level. That's likely going to calm down just a smidge, but I don't want to drop it too far until we get a good look at region 3738. So this is a week that on the Dayside radio bands, it's not pretty. And with the big storms hitting on the sun's night side, or the Earth's night side, amateur radio operators, you guys are just going to have to hunker down and just pray there's no big hurricanes right now, because this is not a good time for radio propagation at all. And I'm hoping things will calm down next week, but we shall see. We have to get through this week first. Okay, so just grin and bear it. And also for you GPS users, same kind of thing. And even you precision agriculture, your farmers, do your best. You may have better conditions on the daytime until you get big flares and deal with some position lock, and signal loss and stuff like that, and then recapture and then signal loss again and just intermittent outages. If you go to the night side, that's when your tractors may actually be like turning circles and chasing their tails. It depends upon how bad the storm gets. So if things aren't working during the daytime, try the nighttime. If things aren't working so well on the nighttime, try the daytime. Just try different periods of operation and things may work out better for you. But yes, it could possibly affect your RTK systems as well, as we've seen with the Gannon storm. So, all right, and now as we switch to our radiation, storm, and polar aviation outlook over the coming week, we are sitting at the D1 normal range right now. Everything is quiet. This is at flight level 360 for you aviators. It's also the S0 quiet range for everybody else. We're sitting with about a 20% chance of S1 to S2 radiation storms. At the moment, I'm going to pop that risk up to maybe about 25% as we move close to the end of the week, and that's because that cluster with region 3764 and 3766 and 65 and 67, there's so many regions that I think we probably will see this rise a little bit, even though we will lose region 3762 off the west limb. Again, this doesn't really factor in the old region 3738, which we know did fire some radiation storms on the sun's far side. So this, especially as we move out past the 5-day, things may change quite rapidly. Okay, so that's pretty much what we have right now. Definitely check those ICAO advisories often if you are a pilot. or even a UAV flyer, because you're going to want to know when, when we get those radio blackouts, especially if you're doing SNR or reconnaissance. It can be a real pain for you, on the Dayside or anywhere near dawn and dusk as well. Okay, and that, I believe, is pretty much all I have, and we can go into a deep dive, and I can talk a bit more about the, let's see, I'll just show the sun a little bit, and we can talk about the deep dive, talk about the storms that are hitting, and we can go into some of the solar flares that have been popping off over the last couple days, and some of the stuff that I didn't quite make it into this forecast simply because I had to turn off the data machine so I could jump on the editor and get this stuff ready for you. So that's it, guys. Hopefully that wasn't too long for, for the BLUF. And we'll jump into a deep dive. I don't see where my time is, how long I've been on live. How long have I been on? 38 minutes, a little bit longer than normal, but hopefully not too bad. Let me put the chat on real fast so we can take a look. And I'll see if I can answer some questions for you. Okay. Oh my goodness, look at the chat catch up. Yikes, I can't read that fast. So, okay. Spinning tractors, so it's moving too quickly. Oh my gosh, how far south will the Aurora be? Likely, if it's going to be a G3, it's going to be, you might be able to see it as far south as like the upper tier of Arizona, right? If you're in central United States, you might be able to see it. If you're in Austria, for instance, in Europe, and you go up high, or if you look at some of the webcams over the mountain ranges there, you probably will get a chance to see it. I'll switch in just a second to the real-time data so you can actually, we'll talk a bit more about the intensity of the storms that we're seeing thus far, and go look a bit more deeply. But yeah, I would pay attention because things are going to ramp up slowly, and the later storms might even be more intense than these. So just pay attention. You definitely have a good chance for some decent shows. It's not going to be like the Gannon storm, though. It's not going to be down to Venezuela. Okay, so that's yeah. So just be aware of that, and know that don't believe all the hype on YouTube. People are talking about a kill shot. There's no kill shot here. Will Aurora be visible tomorrow night? Yes, most likely. So as long as the magnetic field orientation of these solar storms are the right way, we will see some Aurora. And right now, I think, well, when I last looked prior to this briefing, the field was pointed northward, and that's not conducive for Aurora. So we will get a big bump likely in the KP index, but we may not have decent Aurora show yet. Okay, at least not at mid-latitudes. So we have to make, oh really? BZ made it to -12 and it's starting to climb a bit. That's Gunslinger. Thank you for that. I appreciate that. Yeah, we'll take a look here in a moment. Strange is the new normal. Yeah, it's just solar maximum. It really isn't, it's really not that big a deal, to be honest. This is reminding me, as I've said before, this is reminding me more of solar cycle 22, which are the cycles that I grew up with when I was in grad school. Cycle 23 was the anomaly. So everybody who thinks that, oh goodness, this is the, this is so unusual and it's so abnormal, and no. Cycle 23, the quiet cycle, was abnormal. And sadly, that's when we started getting really good with all our cell phone technology and stuff like that, and GPS and blah, 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 and putting it in consumers' hands. That was the wrong time for the sun to go quiet, because we've become very complacent and we don't realize what the sun is capable of, even on just a normal day. Okay, let's see. What would be the best time to step outside and look for Aurora? The best time, honestly, well, obviously at night, right? You're not going to see much during the day. I'm sorry for being flippant. But I would probably start, depending upon where you are, of course, if it's nighttime, well, obviously you can start looking tonight if it's going to be nighttime here soon. On the West Coast, we still have daylight. But over the next couple days, I would think within about 24 hours from now, we'll be close to the peak. But it's hard to say because we have to get that magnetic field orientation the right way. So the best thing to do, honestly, is talk to, get online, look on social media, especially Twitter, ex-Twitter, if you want to call it that, because that's where the biggest grouping of us and all the meteorologists and all the space weather forecasters and scientists kind of congregate and talk about real-time effects. And that's where everybody, also all the citizen scientists, post their aurora photos. So if you want to know when and where aurora is happening, that is the place to be. So that's the best I can give you in terms of that. Okay. Snowing here in mid-Canterbury. Oh, I'm so sorry, Josie. That's terrible. Yeah, well, over the next couple days, hopefully you'll get a chance for things to clear up for you. Okay, Nixon fire east of Temecula. Yeah, I know. Some of us are dealing with some serious fires, and it's just really nasty. Let me, hold on. I just accidentally moved this. I don't want to move this. I want to keep it there so I can see what you guys are chatting. What is the chance of those close sunspots? This is Kev? I can't tell. What is the chance of those close sunspots combining into one large sunspot? Well, they won't. The ones that have the same polarity might come in and coalesce, but if they have different colors, that's magnetically, they're not going to. They're going to try to pull past one another. And so they won't really coalesce into a single spot. It doesn't really work like that. Think of sunspots as submarines, right? Like in a big sea like this. So the surface of the sun is like a big ocean, and these sunspots kind of like periscope up. They kind of are buoyant, magnetically buoyant. So they rise to the surface and they break the surface, and that's when you see them. And then they'll dive back down under the surface. So think of submarines trying to merge. They're not really going to. They might collide and bang into each other, and that may reorganize them, and that's when you get big flares. But they're going to, they'll submerge and change. So you're not really looking at the entire, the full object. You're just looking at the surface and seeing what's going on right at the surface. So it's a bit more complicated than that. Okay. Earth pole shift information. This is Reese. Do not worry about the pole shift, okay? What you may see with these big storms is that we might have a little bit of equatorial aurora. So people in Portugal might see aurora. People in Hawaii might see aurora. People in Brazil and Chile might see a little bit of aurora. And they won't see it as a discrete aurora like the green, the pillars and the pretty, undulating things. They'll see it as this diffuse stuff, kind of like the big SAR arcs. We'll likely see a big SAR arc with this, if not, something glowing that's big red, kind of like a red sky. That's just because of the dynamics. When you have these big storms, they're able to penetrate to a point where they are able to excite certain parts of the, should I get into it? Certain parts of the ring current and then plasmasphere, and there's all these names. And because of the nature of how the particles are penetrating and precipitating into the upper atmosphere, that becomes much less undulating and dynamic. It becomes more diffuse looking, so it's kind of soft. And that's the way equatorial aurora looks as well. And we might see a bit more of that as the poles shift, because now we're beginning to see the effect of the quadrupole field, where the South Atlantic anomaly is actually stretching into possibly 2 poles. But the quadrupole field is definitely strong enough to withstand and stand off the solar wind. Don't worry about it. Tests have been done. Models have been run. We are fine. We've done this. Our Earth has done this many times. And on top of that, it makes the GICs, the geomagnetically induced currents, weaker, which is wonderful for the power grids. Actually, I wouldn't be surprised if that's what helped with the Gannon storm, because we didn't have nearly as many power grid issues as we have in the past. And that's likely because GICs, not only have we trained the power grid utility folks to be better at what they do and know how to mitigate through these big storms, but also I wouldn't be surprised if it's because the GICs are a bit weaker than they used to be, which is nice. And they're still strong, but it's not quite so bad. Okay, Mike Richardson, I see it. Okay, must be on your end. I'm sorry, Stephanie, if you're having trouble. Okay. So Wages World was doing a live stream, but he had to end it due to a tornado warning. Oh my goodness, I hope he's okay. Thank you, Linda. Please, if you see him, tell him, I hope he's all right. Yeah, terrestrial weather is a bit more immediate, isn't it? Yeah, not good. Luckily here in Los Angeles, we don't have weather, we have traffic. Traffic is our weather. We have a blizzard on the freeway. That's about all we have. Earthquakes and traffic. So yeah, outside of that, very few weather issues to deal with. Ham operator says, Tamitha, thanks so much for helping keep hams informed. You're very welcome. Yeah, I'm sorry you're going to have trouble over the next few days with this stuff. But if you are doing RIs or races and, you know, helping out or in the Cajun Army or doing any of the hurricane watch nets, if any are activated, I don't see anything on my geochron right now showing me any big hurricanes. Good. So if that happens to arise in the next couple days, you know, just know that you need to switch frequencies quite a bit. On the day side, go up to higher frequencies. On the night side, go to lower frequencies when the storms hit. That will help mitigate some of the issues. Okay. Viewing possibilities in the Mammoth area. Yes, if we get to a G3, yes, it will be possible. As a matter of fact, I'll go ahead and switch to, yeah, Linda, I see that, and thank you. I understand that Wages World, he talks highly of me, and I speak highly of him as well. And I think he's actually chatted with me a few times in comments. Let's see. So let me do MU teaching. Okay. So I have switched to my live feed here. So you can see, goodness, look at this. Look at just since the 27th, right? This is where our X-ray flux was. This is where our X-ray flux was, right? Sitting at here's the sea floor. If you can see that little line. This is where we were for the X-ray flux until the 27th. Wham. Right here is the beginning of the 27th. This is why I showed the data from that point on. It's because this is when everything gets really interesting. And if you notice, we get clear up here to the M floor. Okay, and we're just below the M floor right now for the noise. Look at this line. Just barely hovering below the M floor. And, you know, I think I got data up to about this point here. I think I was just catching the edge of this flare right here in the data. So I caught the X flare, but you know, there's been 1, 2, 3, maybe 4 M-class flares since then. I just couldn't catch them all. But as you can see, we've had quite a bit of activity, with the biggest being an X 1.5. Correct me if I'm wrong, this was from region 3762, right? If I'm correct, that's the biggest one is. But we've gotten quite a few near X-class flares from region 3766 as well. So a lot of activity here. Now let me switch quickly to the real-time solar wind. Oh, this is looking pretty. Oh, hello. Okay, this is more like it. Yes, yes, yes. I love it. Okay, so as you can see, I like solar storms. Don't be afraid. This isn't a planet killer. It's not even close. This isn't even 20 nanotesla. Okay, for those of you who are. So what we are looking at is upstream data at L1. Okay, so this is about when the solar wind is moving at about 485, not even 500 kilometers a second. So this gives us about 40 minutes, 45 minutes head start. So this is just upstream of Earth. So this data is just beginning. Let's see, how many hours is that? 1, 2. Okay, so each one of these ticks is an hour. So we are just beginning to really start warming up, and I'll take a look at the AE index here in a minute to really kind of see this. But this is what when I started the stream, I was looking at the data, and I think it had just gotten to here. So I was expecting, I'll turn it on to when we do the deep dive, and I'll take a look at the data, and it'll probably be all northward, and it'll be all bummer. But this looks nice. So we've switched now to southward magnetic field. This white stripe here, this white line is the total magnetic field strength. The red line is the northward-southward component. You can tell it's northward if it's above 0. See where that says 0? So anything above 0 is northward. Anything below 0 is southward. So yay, yay, yay. This is fun stuff. And anything above 400, so I jump down to the speed, which is here. You can read the tick lines here. Go from 300 to, what is that, 600 kilometers a second? 3 to 6. So right now we're sitting just below 500 kilometers a second. Okay, not too bad. Remember, these are the weak solar storms. These were the first 2 halos that were coming back to back. That's pretty nice if we're sitting at 500 kilometers a second for them and almost a 20 nanotesla field. This could give us some decent storming. Definitely G2. If this stays southward through the whole thing, goodness, we could easily hit G3 just from this first storm. So then I say, well, the chances of a G4 increase, okay? But to get the auroral oval to open up and give us some aurora begin to move down to mid-latitude, you need about a speed of about 400 kilometers a second. That's a rule of thumb, okay? And you need a magnetic field intensity, southward magnetic field intensity of about a little bit more than -5 nanotesla. So we've got some decent magnetic field here. We're sitting at, what is this? -11. It's almost double that, okay? So yeah, we could get some decent impacts from that. Let me look up real fast AE index, for those of you who do not know. Kyoto. Whoops, I had it. Oh well, one extra click. Today. Let's see. Nope, not doing much yet. So this is, the AE index is basically the auroral electrojet, and it means it's showing us what the currents are. It's kind of like the jet stream for terrestrial weather, but it's in this case, it's more for electromagnetic fields, right? So what we're looking at here, what we want to see is this thing begin to peak up to above 500. Once you start peaking up above 500, this top line here, then you're starting to get actual substorms. So Aurora is brightening. So we're not quite seeing that yet, but it will begin to happen. Likely because we barely, this thing is just barely hitting Earth. We've only gotten about an hour of this at the upstream monitor. So Earth is just beginning to see it, right? So where we're seeing it here, and it's already passed us this far, Earth is only beginning to experience this flip, okay? So it's just going to start building, which is nice. Now let me just check the other components really quickly. Oh, and I'm just taking a look at it, just trying to see if I can see anything in there. Is it coherent yet? No, I don't know. We have a few planar structures which definitely show magnetus sheath for those who recognize planar structures. Noi, if you're watching, here's your headaches. Right? You don't like these planar structures. Here's one, here's another, here's another. It's when the field goes flip, 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 and it goes like a box car, box down. Some people who are geomagnetically sensitive really don't like planar structures in the magnetic field because it makes the Earth ring like a bell, and it just sets up these vibrations and these standing waves that are just nasty. And we're trying to learn more about how that affects people. But there are geomagnetically sensitive people who just don't seem to do well with those. Speed continues to ramp up, so that's telling us that these structures are being compressed, likely, but not very much because we're not seeing really super intense, we're not seeing density continuing to ramp up. So we'll just have to watch it more closely over the next, obviously. I'm going to squish it all together really tightly for a second just to see if I can see trends. Yeah, density's it's not showing much of a trend, but the acceleration sure is. Okay, so I think we're still in the magnetus sheath of this, so we're the front. We haven't gotten to a solar storm core or anything yet, so we've got a long way to go. But it is just beginning to ramp up. It's going to start looking good. I'm going to check HP 30. If you guys don't know what this is, these are very much like the KP index, but they are done instead of 3-hour averaged. They are done every 30 minutes to 60 minutes, depending. Let's see. Do you guys do 10 days for each? Yeah, but it's too much. Let's just do daily. So, yeah, you don't give me the... Man! So HP 30 right now is sitting, or when it hit was sitting at about a 5.5, so it didn't impact all that hard, but what that means is, that's storm level, right, for half an hour. So we definitely got a little bit of a I don't know if it was enough to be a sudden storm commencement, but it was enough to give us a nice little jolt. So the chances of you seeing active conditions to possibly storm level with KP, it's possible. Here's the HP 60, so a 60-minute average jumps us up to 4.5 with it back down to 3, and it'll jump back up again. So yeah, we probably will see when KP is ratchets up a level, which it hasn't yet, as you can see here. Whoops, that's a terrible rendition. Let me just blow it up. As you can see, KP is not up high yet. Okay, we're still waiting. It will probably jump up to, I would say, 4 to 4.5. It might jump up to 5 depending upon how long this takes. But I don't think you're going to see it jump up to a G2. It'll be probably if you had to average it, I would say it would be a KP of 5. So we'll hit minor, likely start off with minor storm conditions, and then we'll build from there. Okay, so from that perspective, the forecast isn't doing too badly. And again, if I go to NLAW, here we can actually play the whole thing. I'll make it dark here. So here we can actually play the whole thing out and get out of the way so you can see the whole thing. So you can see how they, you know, and there's got one left over here. This does not include, if I go back just a smidge, the last storm, this guy here, does not include the at least one, if not two. I think it doesn't include, because this run says run time was 7:29:19. So this doesn't include like storm 9 and 10, I don't think. So you might see another model later that has storm 9 and 10. But as you can see, some of these storms are only partly Earth directed, if I'm not standing in the way. Some are weaker. I don't even know if that's a storm or if that's a just an echo. But this one is partly Earth directed, and as you can see, they do show, you know, impact of these structures, but pretty weak. But then again, you know, we're sitting at 60 particles per cc. So down here is like 10 particles per cc. So it looks like there's nothing there, but there really is. So that's why I say look at the velocity profile to get a better idea of the length of the impacts. You know what I'm saying? If you want to get an idea of when do I go watch Aurora, anytime in this area. Okay, so even when I'm done, you can just go look at this on the Space Weather Prediction Center page and get an idea from there. Okay, and I think, guys, that's all I have. So let me answer other questions if you haven't. Thank you, Jerry, for putting that up. Yes, if you join us on Patreon, of course, you know half of this stuff before I even do a live feed, because I'm chatting with people in the we have a welcome lounge, like a group chat that I oftentimes, kind of like a little private Twitter that we post stuff on, and then I also do internal posts just for Patreon people, so that I can be a bit more chatty and a bit more casual, because I consider everyone in Patreon to be, you know, like family. And so they don't mind if I mess up or accidentally leave an expletive in my forecast, which I did once a long time ago. I've been much better since then. I messed up a scene, and yeah, that was terrible. But, you know, let's live and learn. So that's, you know, a little bit more behind the scenes stuff goes on back there, but you get a lot more insight as to what's going on, and I'm a lot more, you know, when I answer people's questions. Which reminds me, let me check Patreon to see if anyone has asked any questions on Patreon who did not join the chat with us here or was unable to. Let's see. Hold on a second. Oh, yeah, there it is. Okay. All good from New Zealand. That's Kathy O'Neill. Steffi B says red shirt, and Victoria Christensen said, maybe a bit unrelated, but I remember seeing an article during the last solar cycle where the sun's magnetic pole reversal was described. Got me thinking, how do you actually tell when the sun's south pole or north pole has flipped? I also wondered if the sun's magnetic pole reversal is why we often see two peaks during solar maximum. Yes. Okay, so we're talking about the sun, not the Earth's magnetic pole reversal. So when we talk about the sun's magnetic pole, at solar maximum, as we cross through solar maximum, that's when the sun's dipole component of the field flips. A lot of people don't realize this, but every planet, every star that has every celestial body that has a magnetic field doesn't just have a single magnetic field. It has a huge set of them. Just like every sound, it's pretty much any sound that is made in nature has harmonics, okay? Now, the fundamental harmonic, right, the fundamental tone for the magnetic field of anything is typically the dipole field. Well, I shouldn't say it's typically. It is the dipole field, okay? It's the largest of the fields. It has two poles, and it's the one that everybody notices, right? It's the one that is dominating during most times. But Just underneath that, a little bit weaker, is the quadrupole field. Quadrupole field has 4 poles. Okay? Just below that, a little bit weaker than the quadrupole field, is the octopole field. It has 8 poles. Beginning to see this, how this works, right? It's a series. And to be honest, it's an infinite series. Just like harmonics, you have, if you think of sound waves or electromagnetic waves, you have you can have a fundamental that has, you know, a trough and a peak. You can have a full wave, which then has 2 peaks and 2 troughs, or 2 nodes rather, 3 nodes actually. And then you can have more higher harmonics that have more little waves, and they all can be held, like all pinned in the same space. And they're just considered harmonics of each other. You can actually do this with jump ropes, right? You can take a jump rope and you can make a big single wave by rolling it in a circle, and you can just have the jump rope look like this from the 2 edges, or down like this from the 2 edges. Or you can shake it and have it do one of these. Or if you shake it faster, it can have more wiggles, but it still stops at the nodes, at the 2 edges where you hold it, right? Those are harmonics, and those are higher harmonics. The analogous, the analogy to, or the analogous, what should I say, system, when it comes to magnetic fields, and a lot of other, we actually have it in sound waves too, depending upon how you're looking at it. But the analogous system, at least in magnetic fields, planetary magnetic fields, and celestial body magnetic fields, is this dipole, quadrupole, octopole, and higher level components. Now, when the sun reverses its field every 11 years, it's only the dipole component that's reversing. Okay? And even though you'd think that it would be when the dipole field is its strongest, that is solar maximum, it's not. It's actually when the dipole field is in the middle of reversing, when it's 0. And we have what we call a multipolar sun. That's when the field is weaker, but it's very, very complex. And because of the complexity, that's why we get things like solar flares and all this transient weather. It's shedding all of this magnetic flux and energy as that dipole field is reconfiguring. And I do mini courses on this. You can look at sunspots and I think it's called Sunspots and Telescopes, where I talk about it. I don't know if I've done a recent one on a more recent one than that on the magnetic field of the sun. I'm trying to think. Did I do another one other than Sunspots and Telescopes? I can't remember. I might have something in. Well, I do have something in or I think it's the E series, which is or the H series, the Breathing Heliosphere series, because I talk about the solar cycle. But it's literally when that dipole field goes to 0 and the quadrupole field takes over, that's when we get a lot of solar flares. And how you can tell, not only is it because it's extremely active like now, but the polar coronal holes go away, because when you have a dipole field and everything's very well ordered, not only do you not have any space weather, not at least quiet space weather, only fast and slow solar wind, but you have 2 coronal holes at each pole, in the North Pole and in the South Pole, and you have no sunspots essentially, and you have just a very the magnetic equator on the sun is basically the same as the geographic equator. It's almost completely straight. But during magnetic pole reversal for the dipole field, the sun's magnetic field looks like a lava lamp. I mean, there's just islands of magnetic complexity everywhere. There's poles everywhere. And you'll have big coronal mass ejections, big solar storms being launched from the poles. And you won't have any coronal holes at the poles. There'll be little splotches all over the solar disk, and pretty small. So it's a very interesting set of dynamics that we undergo. And maybe I should do another mini course at some point that really goes into that in detail. The reason why we have 2 peaks oftentimes is because the northern hemisphere and the southern hemisphere magnetically of the sun, they don't always concert. They don't always, they're not always agreeing with each other when solar max or solar min should be. And so if they're offset and out of phase, that can actually cause double peaks. And how I talk about it is if you take sunspot number, and you take my hand, for instance, being small sunspot number, peak of the sunspot number, and back down to small. So that would be the solar cycle, right? Minimum, maximum, minimum again. Think of that as not just for one cycle, but 2 hemispheres, Well, if they're both aligned, then you put one hand on top of the other and they add. And so you get a really tall peak and it comes back down to minimum. That activity cycle is really narrow, or it doesn't last all that long, but it's really tall because you're adding these two together and they're doubling each other. But when the two cycles are out of phase and they don't agree when solar maximum should be, then they're aligned not on top of each other because they don't happen at the same time. One happens first and then the other. So what happens? Well, you start at a minimum, you go up to a peak, see this hand, there's one peak, then it kind of dips down a little bit, and then it goes back up to a second peak, and then it goes back down. And look how wide it is, right? So it's not as tall, but it's a lot more wide. So that's what the double peak is. So typically, solar cycles that are weaker last longer, okay? So instead of 9 or 11 years, they last 14 sometimes. And they don't go as high, they're not as high in activity, but they last longer, and they typically are double peaked. And the amount of the double peak really kind of talks about, really speaks to how much in disagreement the two hemispheres are. So if they're really in disagreement, they really don't like each other, right? They don't. One wants to go to solar max, and the other one's like, nah, I ain't feeling it. Well, then the two peaks will be really far apart. But if they're both almost aligned, where one's just 5 minutes late, sorry, honey, I forgot the keys. Let me come back and get it. All right, I'm out the door now. Right, so just a few minutes late. Well, then the two peaks are pretty close together, and you can't even tell that it's a double peak. See, just like my hands are overlapping. You can't tell, but if they're really spread out in time, well, then you begin to see that double peak. Make sense? So the more or less that they're overlapping, really it's talking about what we call this hemispheric asymmetry, which is something that we're just beginning to understand. But it really has a lot of implications in terms of not just the strength of the solar cycle and its length, but also the complexity of the events that come. Some of the biggest events that we have, Carrington-class events, they come with not the big cycles, but the smaller ones, because the magnetic field complexity is so much higher, because the two hemispheres aren't in agreement with anything. So they're magnetically arguing with one another, and that makes activity a lot more intense. There's less activity, but the activity that we have can end up being where we get the extreme of the extreme events. So it's an interesting dynamic there that we're still beginning to unravel. Hopefully that's an okay explanation for you. So there you go. Okay, any other questions, guys? I know it was a long-winded answer, but I am going to, let's see, I'm going to go back to take a look at see if we got any more updating here. Are we still looking good? Yes, we are still looking good. Magnetic field has kind of wiggled a little bit, but it's still down. So it's still staying southward. And let's see if AE is beginning to respond. Yeah, a little bit. Look at there. It's the beginning. People up in high latitudes are going, yay! So we'll see. We'll see. So we're just beginning to start to have fun. So go out there and enjoy. Okay, don't freak out. Everything is going to be fine. This isn't as strong as the May 10th storm, and there should be some real good chances for Aurora for you. Okay, guys? All right. I will, no blue screen of death. It's not going to cause that. Okay, guys. Have a good one.